The e-learning content for self-paced learning I am going to produce is based on choppers. All right. So first of all, we are going to look at the definition of choppers in general, the types of choppers, and look at one of those types in particular. All right. So first of all, let us look at what is a DC chopper and why it is called a DC chopper. All right. Here is the course outline. We're going first to have an introduction of choppers. This is where we're going to define the choppers. We're going to look at the types of choppers, which is a step up a chopper and a step down chopper. So we're going to see what it means when we say step down and what it means when we say a step up chopper. Then we are going to look at the methods of control. Then a step down chopper with a RL load. All right. So first of all, what is a chopper? A chopper is a static device. That definition alone might not be enough. So a chopper, from the sense of chopping in English, when we say chop, it means to cut off. So it's basically the same here, chopping and cutting off. So we're saying a variable DC is obtained from a constant DC source, which means variable in this sense, it means maximum 0, maximum 0, maximum 0. So clearly at certain times we are going to chop or to cut off the voltage. That's where the chopper comes from, a variable DC being obtained from a DC voltage source. It is also known as a DC to DC converter. All right, which means it simply means the statement we have said above, variable DC from constant DC. So it's a DC to DC converter. Here we see its application in motor controls, regenerative braking. Then we are being told that the thyristor converter offers greater efficiency. This is just why we have this choice of certain components to others in the chopper. All right. Let us look at the types of choppers. We have two main types of choppers: step down chopper and step up choppers. Right, as I said in the introduction, when we say step down, the output voltage is less than the input voltage. So we have step down the voltage. So step up is the opposite of step down. The input voltage is smaller than the output voltage. We stepped up the voltage. All right, let us look at the principle of operation of a step down chopper. This is the one we are going to basically look at. Here's our step down chopper. So here V is the source of voltage, and then here we also have V. So the input is V and then the output is V naught. So from this diagram, whether it's step up or step down, we are going to see, based on the comparison between V and V naught. So if V is bigger than V naught, it's a step down. If V naught is bigger than V, then it's a step up chopper. All right. As we continue, this one is a step down chopper with a resistive load. We've seen that. The thyristor in this circuit is acting as a switch. When you say switch, we mean just like the electric switch, they turn on and off. So when we say switch, it just means at a certain time it's on or it's at maximum, then at another time it's zero. That's basically how a switch works. 1 0 1 0 1 0. All right. When the thyristor is on, supply voltage appears across the load, which means V is equal to V naught in this case. Then when it's off, V naught is equal to 0. So we have a situation like this. Let me just put a small sketch here. When the thyristor is on, here's our sketch. Here's our sketch. We have V here. So when the thyristor is on, this is V naught in this direction, and this is time. When the thyristor is on, V naught is equal to V. When it's off now, V naught is equal to, we're going to see a better diagram than this below, but this is basically the type of graph which we are talking about. All right, so we have it here. T on just means the time when the thyristor is on. V naught is equal to V. When thyristor is off, V naught is 0. Then we're also going to see what is VDC as we progress. This is also the current. Remember, current and voltage, they are directly proportional. So it's suiting that we have a graph of a current below. VDC is the average value of output or load voltage. We're 0 and maximum. So what the average is in between there. So in case someone wondering why it is being called a step down chopper, we are comparing V to VDC because VDC is now the output voltage. Right, some of these are just definitions of what is already on the graph. Here is how we calculate VDC and so on and so on. All right. After seeing this, we progress to the methods of control. Here we can change the output voltage. Right, how can we change the output voltage? Pulse with modulation control or constant frequency operation, variable frequency control. These are the two ways. Let us see how these two ways work. Right, pulse with modulation. T on is varied, keeping the chopping frequency F and chopping period T constant, which means clearly if you vary T on, we are already varying VDC, unless it's a coincidence, but if we have T on, let's say, is equal to 5 and T on is equal to 10, already we have a different situation, right? Output voltage is varied by varying on time, which is T on. That's what I have already said. As you can see, if you want to compare this graph with the graph above, you can see that T on is smaller now and T off is a little bigger. So having that will simply mean VDC becomes smaller in this case. But if we want to increase T on, like in this case, in the case below, our VDC becomes bigger than the one before. This is one way of controlling our output, right? Variable frequency control. We are varying the chopping frequency, keeping a T on or T off a constant, right? To obtain a full output voltage range, frequency is to be varied over a wide range. The method produces harmonics in the input, and for large T off, load current may become discontinuous. Right, so here it is, T on and T off are constant, but we vary. Right, we look at the step down chopper with RL load. Right, so RL, we just added the inductance to our load. Right, what happens here? When the chopper is on, supply is connected across the load, current flows from supply to load. When chopper is off, current continues to flow in the same direction due to current stored in the inductor. Load current can be continuous or discontinuous depending on the values of L and duty cycle D. Alright, for a continuous current operation, let us see what we're talking about here. Alright, V, we're still having the same on, off, on, off, on, off. But the current now does not come to zero. We just have a minimum and a maximum because the current doesn't stop because some of it is being stored in the inductor. Right, so basically that's it for the chopper. Right, let us look at what we have studied so far. Okay, now we know what a chopper is. What do you mean when we say a chopper? Then we also know what is a step down chopper, what is a step up chopper, and how or in this case we have only discussed the step down chopper, but we know now what a step down chopper is and what result gives us a step up chopper. All right, so thank you. This will be, we also know the effect of changing the load from R to RL. So thank you. This will be the end of today's session.